Good morning to everyone. My name is Andres Velez. I'm a principal data scientist at OfferUp. I'm here to talk pretty much about how OfferUp builds transformative experiences using search with Amazon Bedrock. But for those, I'm curious, raise your hand if you have used OfferUp before. Awesome. Nice. For those who actually don't know about OfferUp, it was founded in 2011. And nowadays is one of the pretty much the largest mobile marketplaces for local buyers and sellers in the US. One interesting fact is 1 in 5 people in the US use OfferUp nowadays. And we have transformed how local communities buy and sell products, and by providing an application in which is unique, simple, and trusted for come up with these transactions. Our mission pretty much is to be the platform of choice for local commerce by connecting buyers and sellers through an interface that makes selling an item as easy as snapping a picture from a mobile device. And we are here pretty much to talk about search, right? So search in general is a really important piece in any application. And this is because by tweaking the search, investing in search, you are able to just like leverage multiple application metrics. So let's imagine this scenario. A user goes to the application, search for a product then, and if the product is personalized, then it is going to save time and effort looking for what they need. Then this is going to, if this process is optimized, then the user finds what he needs and is going to try the steps up. Otherwise, you have insights to improve the platform, to go back and forth and just keep improving. After you apply these changes, then they are going to materialize in the user experience, right? Which at the end is user retention metrics, which are going to be increased. There are multiple types of search engines, and mobile search has its own challenges. The first one is broad and short search query types. Users tend to use approximately between 1 and 5 key like search terms. And this is really complex because you give short context to actually look for what you want. If you look for other search types, engines, you actually generate like more description, you generate more context for your search query. And the other aspect which is challenging is the variation in the quality of the user provide content. And if you imagine, if you look at the image provided here, it's like they are really good quality. They are awesome. However, some users, they provide low quality images, and this is challenging. And if you look to the title and description, some of them are really scarce. They don't just provide so much context to the product. And another I can think of is the limited screen real estate, making good ranking like crucial to succeed in the application. And these are pretty much some complexities in mobile marketplace search. And this is an evolving area. And we at OfferUp, we are working really hard to keep up with the latest changes. And we have begun with that journey, which began with keyword search. And we use keyword search all around the application. This technology has pros and cons, right? And pretty much we use the keywords that the user provides and match it in the engine, right? We retrieve those listings which actually match it. And on top of this technology, we explore neural search. So we start using vector databases. We start exploring OpenSearch. And also, we use Amazon SageMaker to deploy our models built in-house for semantic search. So we took title and description and generated the embeddings, and then we stored these embeddings, we index them in the vector database. Before going to production, we test this new stack of technology in two main aspects. The first one is latency. We want to just like be compliant with the SLAs we have in the company. And the second point is quality. We want to make sure the retrieved listings just actually come out with good results. For this, for the latency, we pretty much perform experimentation. We backfill OpenSearch database to millions of listings. And after we backfill this information, we apply RPS to 100 of our RPAs in the database. For all the scenarios, we see approximately under 60 milliseconds for P99, and this is awesome. We are really surprised, and we are really happy to collaborate with the OpenSearch team at Amazon because it has a great community support. The other experimentation we did is quality. And for the quality assessment, we retrieve items using the top 25 most used keyword search in the application. And with this information, we retrieve certain amount of listings, and we compute the relevance recall. For the relevance recall, we have as baseline, we have as baseline the keyword search. And if we look at the results, there is approximately a 23% increase in the relevance recall by using semantic search for the low-density locations, and a 27% increase in relevance recall for the high-density locations. High-density locations is number of products per area, and that's a really improvement switching to this technology. But if you look at this, there are great numbers, right? But there is a missing piece in all these aspects. And if we look at this image, first of all, it's a really nice deal. I will definitely buy this for my house. And if you look to it, the title is pretty much not really meaningful. And the description is really short, right? But if you look at the image, right, the image gives you a lot of details such as the color, the shape, the number of seats it's being sold, and also the size of the seats. So the image just gives you a lot of more information about this context. And that's why it is really important to take this into consideration. So for this, we are using Amazon Titan multimodal model. And we pretty much integrate this new component, right, in our journey. And we pretty much take the image alongside the title and description. We pass it through the Titan multimodal embedding, and then we index the vector database with this information, which is enables us to search with these new components. Let's imagine this, without this multimodal model approach, we don't make certain listings discoverable. So this is really important. And also from the technical point of view, the partnership with AWS, Amazon, has allowed us to test new technology in really short amount of time. So that will take us to a couple months to build this new technology. And we also tested in terms of quality, following the same methodology I explained before. And with the Titan multimodal embedding model, it has demonstrated an improvement for low-density locations, approximately 9%. And also, it has reduced the variance for both low and high-density locations. This is really, really nice, because at the moment, we haven't applied any transfer learning on it, so it's the way as it is. And if you look at the reduction in variance, it actually makes the system more stable. In general, this journey, to summarize, we began with keyword search, right? And then we started exploring neural search with semantic search. And this yielded 23% for low-density locations and 27% increase in relevance recall for high-density locations. So it has been a great improvement. And then, on top of that, we started exploring new technologies. We started exploring a multimodal embedding technology, which at the same increased the relevance recall for the low-density locations at like maintaining the same performance for the high-density locations without applying any transfer learning on it, and make the system more stable. So you are thinking, what is next? Pretty much, we are researching how we can further leverage AI tools to support search, recommendation, image generation, and more within OfferUp. Thank you.